It's June 1944. The Allies have stormed the beaches of Normandy, a monumental feat. But now they face a new, unexpected nightmare. Not a fortress, not a bunker, but something far more ancient and deceptively simple. The hedgerows. This is the story of how one sergeant's ingenious idea broke a deadly stalemate and changed the course of the war. Just weeks after D-Day, the Allied advance stalled. They were trapped in a labyrinth of thick, earthen walls, some over 6 feet high and several feet thick, tangled with centuries of dense roots and thorny bushes. The French called it the bocage. For the American GIs, it was a death trap. These hedgerows crisscrossed the Norman countryside, turning every field into a natural fortress. German soldiers, armed with machine guns and Panzerfausts, were experts at using them for cover. They could wait in ambush, knock out the lead Allied tank, and pin down entire platoons. The tanks, the spearhead of the Allied army, were rendered almost useless. They'd try to drive over the hedgerows, but this would expose their thin underbelly armor to German anti-tank weapons. A fatal mistake. Trying to blast through was just as bad, often just creating a bigger pile of impassable dirt. Morale was plummeting. The Allied command was desperate. Every yard gained cost an incredible number of lives. They were losing the Battle of the Bocage. But in the midst of this frustration and bloodshed, an unlikely hero emerged. Not a general, not an engineer from back home, but a 29-year-old tank commander from New Jersey, Sergeant Curtis Culin II of the 102nd Cavalry Reconnaissance Squadron. Culin had seen enough. He'd lost friends, he'd seen tanks burn, and he was tired of being a sitting duck. He wasn't a trained engineer, but he was a practical man who understood his machine and his enemy. He observed that while his Sherman tank was helpless against the earthen walls, it was powerful enough to tear through smaller obstacles. He had an idea, one so simple it was brilliant. One night, while talking with a fellow soldier, Culin had a moment of inspiration. He remembered seeing the massive steel beams the Germans had planted on the beaches to stop landing craft. They were nicknamed Czech hedgehogs. What if, he thought, we could take those enemy obstacles and turn them into a weapon for our own tanks? His idea was to weld massive, tusk-like prongs onto the front of a Sherman tank. These prongs, scavenged directly from the German beach defenses, would act like a giant, angry plow. Instead of trying to climb over the hedgerow, the tank would ram directly into its base. The steel tusks would dig deep into the earth and roots, and the sheer power of the 30-ton tank would tear a massive hole straight through the embankment. The tank could then burst through the gap, guns blazing, shocking the German defenders who thought they were safe. It was a brutal, direct, and utterly effective solution. Culin took his idea to his superiors. In the chaos of war, a sergeant's idea might easily have been dismissed, but desperation breeds innovation. His commanding officer, Lieutenant Colonel John Madaris, saw the potential. He gave Culin the green light and the resources to build a prototype. Working with a maintenance technician named Vivian Strock, Culin and his team scrounged scrap metal from the German beach obstacles. In a makeshift field workshop, under constant threat of artillery fire, they forged the first set of these fearsome-looking attachments. They welded the steel beams into a massive, 4-pronged rake on the front of a light tank. The moment of truth arrived. They drove the modified tank towards a hedgerow and hit the gas. The result was spectacular. The tank didn't stop. It didn't get stuck. It tore through the hedgerow like it was made of paper, creating a perfect, tank-sized passage. They had done it. The device was an immediate success. When General Omar Bradley, commander of the U.S. First Army, saw a demonstration. He was blown away. He reportedly exclaimed, "This is it. We can put these on all the tanks." The invention was quickly christened the Rhino for its aggressive, horned appearance. Orders were given to equip as many tanks as possible. An enormous round-the-clock production effort began. Welders worked tirelessly, converting scrap metal from the beaches and even railroad tracks into hundreds of these hedgerow cutters. Just in time for Operation Cobra, the massive Allied breakout offensive planned for late July. The impact was immediate and decisive. When the offensive launched, entire armored divisions, now equipped with Rhino tanks, smashed through the bocage country. German defenders were caught completely off guard. Their once impenetrable defensive lines were shattered in hours. The stalemate was broken. The Rhinos led the charge, allowing the Allied forces to pour out of Normandy and race across France. Sergeant Curtis Culin's simple field-expedient invention had saved countless lives and significantly shortened the war in Europe. For his ingenuity, Culin was awarded the Legion of Merit, a testament to the power of a single soldier's idea on the battlefield. It's a powerful reminder that sometimes the greatest solutions come not from the top, but from the men on the front lines, facing the problem head-on. Thanks for watching. If you found this story of battlefield innovation as fascinating as I did, make sure to hit that like button and subscribe for more hidden histories. They called it bocage. To the Norman farmers who built it, the hedge was not a weapon, but a boundary. Over centuries, fields had been cleared stone by stone, the earth piled into banks 8, 10, sometimes 15 feet high. Roots grew deep and wide, binding soil and rock into something closer to masonry than farmland. Trees took hold. Bushes followed. What resulted were living walls, thick, irregular, and nearly indestructible, that divided the countryside into thousands of small enclosures. From the air, Normandy looked gentle and open. From the ground, it was a labyrinth of sunken lanes, blind corners, and elevated earthworks that offered perfect cover to anyone who understood their value. The Germans understood immediately. 4 years of occupation gave them time to study the terrain, and they transformed every hedgerow into machine guns covered the gaps. Mortars were pre-registered on likely approaches. Anti-tank teams waited where American armor was forced to expose itself. The terrain did the rest. Tanks built for speed and maneuver were reduced to crawling assaults. Air power meant little when targets were invisible. Artillery could not be directed accurately when observers could not see past the next wall of earth and leaves. American doctrine assumed open ground and rapid movement. Normandy offered neither. The first attempts to break through followed the book. Engineers blew gaps. Tanks moved forward. Infantry followed. The Germans simply waited for the explosions and fired into the opening. Variations followed. Smoke, preparatory bombardments, night attacks. But the outcome never changed. High casualties, minimal gains. By June 10th, 4 days after the landings, advances were measured in hundreds of yards. The cost was climbing toward something no commander could sustain, a position. Culin watched the pattern repeat itself. 6 tanks, lost in 3 days, always the same sequence. The Sherman climbed. The nose rose. The thin belly armor faced the enemy. A hidden anti-tank team fired once, then fire and smoke. After the 3rd tank burned, Culin sought out his company commander, Captain James DeLance, whose exhaustion showed as clearly as the strain in his voice. "Why do we keep climbing over?" Culin asked. "Why can't we go through?" Delance gave the answer everyone had already accepted. The hedgerows were too dense, the roots too old, the banks too thick. Tanks could not simply drive through them. Culin pressed again. Has anyone actually tried? Tried what? Driving straight through, full speed, no climbing, just through. Delance stared at him. Those roots were older than the country they were fighting for. 2 feet thick in places. A tank would dig in, lose momentum, and sit helpless under fire. Culin did not argue doctrine. He offered an object instead. What if we put something on the front of the tank? Teeth? To cut the roots as we go. With what? Delance asked. There was no time for proper equipment. No pipeline from England for new designs. Culin gestured north, toward the beaches. The Germans left their steel there. Obstacles meant to tear open landing craft. Rails, girders, thousands of tons of it, abandoned where it fell. Delance weighed the idea against the reality in front of him. Nothing they were doing was working. Finally, he nodded. You've got 24 hours. Get the steel. Get a torch. Try it. If it works, we put it on every tank we can. The next morning, June 11th, Culin was back on the invasion beaches with 2 men from his crew, Private John DePasco and Corporal William MacDonald, walking among the wreckage of German defenses, measuring steel meant to stop the invasion, and wondering if it could be turned into the means of escape. The most promising steel lay half buried in the sand. Heavy rails and I-beams the Germans had driven into the beaches to rip the hulls out of landing craft. They were thick, hardened, already cut into workable lengths, and strong enough to take punishment. Culin ran his hands along the edges and began sketching on the back of a ration carton. The idea was brutally simple. 4, maybe 5 steel prongs, angled slightly upward, welded directly to the front of the Sherman's hull. Not a plow, not a ram. Teeth. The tank would not try to climb. It would cut. As the vehicle drove forward, those prongs would shear roots and lift earth, just enough to keep momentum from dying. The design had to meet unforgiving limits, strong enough to survive impact, short enough not to interfere with the main gun, light enough not to throw the tank off balance, simple enough that any maintenance crew with a torch could reproduce it. There was no room for elegance, only function. Over the next 12 hours, Culin and his crew worked without pause. Steel from a German obstacle, a welding torch borrowed from battalion maintenance, measurements taken by eye, cuts made by feel. The design was not calculated so much as sensed, an instinctive understanding of force, angle, and weight, learned not in classrooms but behind the wheel of a cab and inside the hull of a tank. By dawn, the prototype was finished. 4 steel prongs, each roughly 4 feet long, welded to a flat mounting plate, bolted to the Sherman's nose. The welds were uneven, the spacing imperfect. It looked crude, improvised, almost laughable. Captain Delance studied it in silence. That's supposed to cut through hedgerows? Culin met his gaze. Won't know until we try, sir. The test came on June 12th, at 600 hours. The hedgerow chosen was typical for Normandy, 12 feet high, an earthen bank nearly 5 feet thick, roots from oak, elm, and hawthorn intertwined after more than a century of growth. 2 tanks and 14 infantrymen had already died trying to breach it. Culin's Sherman rolled back 50 yards, its new steel fork jutting forward like an accusation. From a safe distance, Lieutenant Colonel James Bates watched, openly doubtful. Delance gave the order, full speed, don't stop, drive straight through. Culin opened the throttle. The engine roared. The tank surged forward. Grass flattened beneath the prongs. At 20 miles per hour, the Sherman struck the hedge. The impact shuddered through the hull. For an instant it seemed the wall had won again. Then the prongs bit. Steel met soil and root. The earth began to tear. The tank's mass carried forward. Momentum transferred through the cutting teeth instead of wasted climbing upward. Roots snapped. The bank split. 10 seconds after impact, the Sherman's nose broke through. 5 seconds later, the entire tank emerged, intact. A gap nearly 10 feet wide stood where the hedgerow had been. The prongs were bent, scarred, but still held. The crew was unhurt. The gun could traverse and fire. Lieutenant Colonel Bates walked forward and studied the cut. The banks on either side were stable. Infantry could pass through without being funneled into fire. More importantly, the tank that made the breach was still a weapon. Bates turned to DeLange. "How fast can we put these on every tank?" 48 hours if we push every maintenance crew." Bates did not hesitate. "You've got 24. Every Sherman in the 2nd Armored Division gets one. Immediately." A report went up the chain that same day. Lieutenant Colonel Bates did not soften the language. He described a device fabricated from scrap steel, tested under combat conditions, that had solved the hedgerow problem in seconds. He recommended immediate adoption, not as an experiment, but as standard equipment. The effect was immediate. Word moved faster than paperwork. By June 13th, across the Normandy beachhead, maintenance crews were dragging welding torches into fields and motor pools, cutting up German beach obstacles and bolting steel prongs onto the noses of Sherman tanks. No one waited for formal blueprints. No one needed them. The design explained itself the moment you saw it. Soldiers argued over what to call it: the hedgerow cutter, the Culin cutter, the Rhino Tank. But the name mattered less than the result. Tanks that had been trapped now moved forward. The mechanics were as simple as the solution itself. Instead of slamming a tank's mass into a wall of earth and roots, the prongs divided that force into multiple cutting points. Energy that had once lifted the tank's nose and exposed its belly was now driven forward, shearing roots and breaking soil apart. The slight upward angle prevented the tank from piling dirt in front of itself and losing momentum. Nothing about it was sophisticated. That was its strength. Any crew with a torch could build one in a few hours. Steel was everywhere. The beaches provided enough raw material for thousands. By June 15th, more than 500 Sherman tanks in Normandy carried some version of the cutter. Each one represented a quiet but absolute shift. American armor could now move in bocage country without offering itself up to the enemy. The battlefield noticed immediately. Before the cutter, breaching a hedgerow was a deliberate operation. Engineers, explosives, smoke, infantry, armor, 15 to 30 minutes of exposure under fire for every advance. After the cutter, one tank did the job in seconds. 10, maybe 15. German anti-tank teams, trained to strike when a Sherman reared up helplessly on a bank, suddenly found the tank already through. Gun level. Engine still accelerating. On June 18th, during the preliminary actions leading into Operation Cobra, the 2nd Armored Division advanced 3 miles in a single day. A week earlier, that distance would have been unthinkable. Casualties told the rest of the story. Infantry losses dropped by roughly 60% in sectors supported by cutter-equipped tanks. Tank losses fell by more than 70%. A device that looked like scrap metal was saving lives at a rate measured not in theory, but in bodies not buried. The reports reached higher command within days. On June 19th, General Omar Bradley read them with open skepticism. Welded scrap steel succeeding where trained engineers had failed did not fit expectation. He ordered a demonstration. When he saw a Sherman drive straight through a hedgerow that had previously anchored German defenses, the doubt ended. Orders went out immediately for maximum production and distribution. By June 25th, First Army priorities included fitting every available medium tank with a hedgerow cutter. The German response confirmed the impact from the other side of the line. A captured report from the 352nd Infantry Division dated June 22nd was blunt. Enemy armor now penetrates hedgerow positions with unprecedented speed. Defensive tactics based on terrain exploitation are no longer effective. Tanks equipped with unknown cutting devices breach positions in seconds. Recommend immediate adjustment. By the time the recommendation was written, the adjustment was already too late. Another captured document was even more direct. It came from a German tank destroyer commander writing to his superiors after facing the new American tanks. "The Americans have solved the hedgerow problem," he wrote. "Positions that were impregnable last week are now death traps. We cannot stop their tanks anymore. They cut through everything." There was no exaggeration in the tone, only resignation. When an enemy is forced to abandon tactics that once defined an entire defensive system, the battlefield has changed at a fundamental level. The hedgerow cutter was not just a tool, it was a rupture in German assumptions. Its consequences reached far beyond simple movement. With cutter-equipped tanks, American units could finally fight as they had trained to fight. Armor no longer paused and waited for engineers. Infantry no longer advanced alone into narrow lanes. A tank could open a breach in seconds, roll through with its gun already leveled, and hold the far side while riflemen followed. Momentum, lost since the first days after D-Day, returned. German doctrine in Normandy had rested on one core belief: American tanks could not operate effectively in bocage terrain. That belief shaped where weapons were placed, how fire was planned, and where reserves waited. Culin's device erased that belief overnight. Positions built to exploit delay and exposure suddenly offered neither. What followed revealed something deeper than a technical fix. Curtis Culin was 28 years old, a cab driver before the war. No engineering degree, no role in doctrine development, no authority beyond his stripes. What he had was refusal. The refusal to accept that a problem labeled unsolvable must remain so. And what mattered just as much was the system around him. Captain DeLange could have dismissed the idea. Lieutenant Colonel Bates could have delayed it pending analysis. General Bradley could have demanded a formal design from ordnance departments. Instead, at each level, the same question was asked: does it work? When the answer was yes, barriers fell away. Within 2 weeks, the device moved from a single field experiment to Army-wide adoption. The contrast with German military culture was stark. German engineering was often superb. Their weapons and fortifications showed precision and depth. But innovation moved upward slowly, filtered through doctrine offices, testing authorities, and rigid hierarchies. An idea born with a sergeant and a welding torch would struggle to survive that system, no matter how effective it proved in combat. The American response was different. Results mattered more than credentials. Speed mattered more than formality. By July 1st, 1944, more than 2,000 Sherman tanks in Normandy carried some form of the cutter. Intelligence briefings referred to Rhino tanks as a distinct capability, as if they had always existed. The psychological effect matched the tactical one. For 10 days after D-Day, soldiers had watched the hedgerows consume units at an unbearable cost. Morale eroded as every advance ended the same way. The bocage felt invincible, green walls that neutralized armor, air power, and artillery alike. The cutter changed that calculation. The hedgerows were no longer symbols of futility. They were obstacles, and obstacles could be breached. The sound of a tank engine accelerating toward a hedge no longer meant waiting for the explosion and the fire. It meant movement. It meant survival. The cutter altered more than tactics. It changed how the war felt to the men fighting it. The hedgerows lost their power as symbols of inevitability. They were no longer walls that demanded blood before movement. They were obstacles, solid, dangerous but solvable. Steel welded to a tank's nose became visible proof that the situation was not fixed, that ingenuity could still break the logic of the battlefield. A captured diary from an infantryman in the 29th Division recorded the shift with brutal clarity. June the 10th. The hedgerows are killing us. We can't advance. Every attack is a slaughter. 10 days later, the tone changed. June 20th. The tanks have these steel forks now. They just drive straight through. We're moving again. Maybe we can actually win this. That movement, from despair to belief, mattered as much as any reduction in casualties. That belief was tested in the largest gamble of the Normandy campaign. Operation Cobra began on July 25th, built around overwhelming aerial bombardment, followed by rapid armored exploitation. Its success depended entirely on speed. Tanks had to move faster than German units could recover, faster than new defensive lines could form. Without the cutters, that speed was impossible. The bocage would have slowed every advance, channeling armor into predictable lanes and buying the Germans time. With cutter-equipped tanks, the armored divisions did not pause. They broke through. In the first week, American forces advanced more than 60 miles, liberated town after town, and shattered the German defensive system in Normandy. What had been a static battle of attrition became a pursuit. The numbers reflected the change. From D-Day through mid-June, before widespread adoption of the cutter, American forces suffered roughly 15,000 casualties while advancing only a few miles from the beaches. After the cutters spread through the armored units, casualties rose more slowly, even as distances exploded outward. Similar losses, vastly greater gains. Combat was still deadly. Nothing had made it safe, but it had become possible without paying a prohibitive price. Conservative estimates suggest thousands of American lives were spared. Curtis Culin did not see his name attached to that transformation, not through a miracle, but through momentum restored. In official paperwork, the device appeared as a hedgerow cutting attachment, or an obstacle-breaching modification. His name surfaced occasionally at unit level, then disappeared. Part of that was culture. Sergeant-level innovations rarely carried signatures. Part of it was chaos. By late June, there were dozens of variations in the field. Some units used 4 prongs, others 6. Angles changed. Steel sources varied. Each crew adapted the idea to what they had. Establishing ownership was irrelevant. Survival was not. Culin never tried to claim it. In later interviews, he reduced the story to its barest form. I just tried something. It worked. When pressed, he insisted others had thought the same way. He only happened to act first. Credit, he said, belonged to the officers who allowed the attempt. That restraint, common among men who survived the war, helped push his story into obscurity. It would not be fully documented until decades later, when historians returned to Normandy and traced the origin of the steel prongs back to a single Sherman and a single decision made under fire. Today, one of those crude steel devices sits behind glass at the National World War II Museum. Recovered from Normandy in 2007, it is bent, rusted, and unimpressive at first glance. The placard beneath it is more direct than the object itself. It credits the invention to Curtis Culin, a sergeant of the 2nd Armored Division, and states plainly what the battlefield already proved, that this device transformed the Battle of Normandy and saved thousands of American lives. The cutter looks out of place in a museum filled with aircraft, artillery, and medals. It has none of their polish. That is the point. It was never meant to last. It was meant to work. Culin did survive the war. He fought through France, Belgium, and into Germany with the 2nd Armored Division, and received a Bronze Star awarded for meritorious service without mention of the hedgerow cutter. When the war ended, he went home to Cranford, New Jersey. He returned to driving a cab. He married. He raised 3 children. He lived quietly. Friends and neighbors knew him as a working man and a veteran, not as someone who had altered the course of a campaign. He almost never spoke about the cutter, unless asked directly. In a 1983 interview, conducted after historians finally traced the device back to him, Culin dismissed the idea of invention. "We had a problem," he said. "Nobody had solved it. I figured we should try something different. It worked." When asked if he felt proud, he paused. He said he was proud they won. Proud that men made it through those hedgerow gaps alive. What stayed with him were the ones who did not. The men lost before the solution existed. If anything, he said, he wished he had thought of it sooner. Curtis Culin died in March 1963 at the age of 47. His obituary mentioned his service briefly and focused instead on his family, his work, and his place in the community. The hedgerow cutter was not mentioned. That absence mirrors how the device lived in history for decades. Essential, transformative, and largely anonymous. Yet its influence did not end in Normandy. After the war, armored vehicle design increasingly incorporated obstacle-breaching capabilities as standard. Modern combat engineering doctrine emphasizes rapid improvisation with materials at hand. Military training programs use Culin's story not as a tale of genius, but as a case study in decision-making under pressure. The lessons endure because they are uncomfortable. Expertise can become a constraint. The engineers who declared the hedgerows impassable were not wrong in theory. They were limited by doctrine. Speed matters. 2 weeks of hesitation would have cost lives that were instead saved. Simplicity scales. A crude design that anyone could replicate mattered more than a perfect solution that arrived too late. Culture decides outcomes. A system willing to listen to a sergeant with scrap metal succeeded where rigid hierarchy would have failed. And individuals still matter. One decision, made without permission from history or precedent, changed the trajectory of the Normandy campaign. The cutter itself is nothing more than steel prongs welded together in a field. But those prongs broke more than roots. They broke an assumption that some problems must simply be endured. In Normandy, that assumption was costing lives. Curtis Culin did not accept it. He tried something different, and because he did, the war moved forward. The Culin cutter represents something deeper than a battlefield adaptation. American victory in World War II did not come only from factories, tonnage, or numbers on a production chart. It came from a culture that allowed ordinary people to confront extraordinary problems, and then moved quickly when their solutions worked. In Normandy, doctrine said the hedgerows were impassable. Experience said they were lethal. Curtis Culin did not argue either point. He ignored the conclusion. He treated the hedge not as fate, but as a problem that had simply not been solved yet. That countryside still carries the evidence. Across the bocage of Normandy, gaps remain where tanks once forced their way through. Farmers working land their families have cultivated for centuries still turn up rusted fragments of steel while plowing, bent prongs, broken welds, pieces of a solution improvised under fire. They are crude, unimpressive, and they changed history. Those steel forks turned an unsolvable tactical dilemma into a manageable obstacle. They saved thousands of lives. They made the breakout from Normandy possible, and that breakout made the liberation of France and the defeat of Nazi Germany possible. It began with a single question asked by a cab driver from New Jersey wearing a Sergeant S stripes. Why can't we try something different? The answer was that they could, and when they did, it worked. That is how wars are often won, not through perfect plans or flawless weapons, but through people willing to think differently, act decisively, and accept responsibility when failure is possible. A welder, scrap metal, 4 steel prongs. That was enough. The hedgerows of Normandy had defeated armies for centuries. They finally met an obstacle they could not stop. Not because it was sophisticated, but because it was applied with courage and common sense. The German beach obstacles built to repel the invasion ultimately contributed to Allied victory, just not in the way their designers intended. Turned against their purpose, they became tools of breakthrough rather than defense. That irony captures something essential: adaptation over doctrine, results over process, innovation over convention. Curtis Culin never called himself an innovator. He said he was trying not to get killed. But in refusing to accept that the impossible must remain impossible, he altered the course of a campaign. Sometimes the most powerful weapon is not manufactured in a factory. Sometimes it is welded together in a field by someone who simply refuses to stop. 4 steel prongs on the front of a Sherman tank. That was all it took to change history.